Academic research is buckling under a quiet crisis. When scholars try to force highly sensitive, rigorously structured work through standard AI tools, the results often fail the strict demands of institutional review. The error is mechanical. It stems from treating artificial intelligence as a simple search interface or a hands-off automated pilot. Relying on a single prompt and treating the output as a finished product leads to hallucinated data and compromises the core methodology of the study. This diagram maps the functional difference between a system that fails academic rigor and one that supports it. To operate safely, a model must function as an engine for integration rather than a tool for simple retrieval. On the left, the traditional search paradigm pulls isolated, disconnected facts. Without a broader context to ground the logic, the model often invents connections to fill the gaps between these points. The right side illustrates a synthesis engine. It applies inductive reasoning to a specific set of user-supplied data, integrating complex variables into a verifiable, interconnected structure. Safely integrating AI into the scholarly workflow requires building interconnected, specialized tool ecosystems that can handle these complex integrations. Mastering this architecture allows researchers to process vast amounts of literature at high speeds, while maintaining a verifiable audit trail back to the source data. Academic integrity rests on the absolute protection of participant data and unreleased intellectual property. Uploading raw focus group transcripts or draft manuscripts directly into open generative AI models creates an immediate security vulnerability. This schematic maps the risk. Open systems on the right actively mine uploaded files to train future models. Any proprietary research entered here becomes public knowledge. To maintain IP control, scholars must operate on the left side, utilizing a closed retrieval augmented generation, or RAG environment. A RAG system functions as an isolated digital vault. It restricts the AI to constructing answers purely from the specific sources you upload, executing with zero external model training. This matrix categorizes tools for a privacy-first strategy. Notebook LM is the primary closed system, operating on a zero-training data model. Gemini Pro is the open system. Its generative capabilities must be strictly confined to public ideation and formats where IP is not at risk. By routing sensitive data into the closed vault and utilizing the open LLM purely for structural ideation, the researcher protects IP while gaining synthesis velocity. In practice, the heaviest bottleneck a researcher faces is the execution of a systematic literature review. No single platform can handle the search, synthesis, and ideation phases simultaneously without compromising quality. The solution is a specialized three-node pipeline. This diagram maps the triangulated research loop, a continuous cycle utilized in advanced academic workflows. Node 1 is the foundation. Scopus AI acts as the deep search mechanism. It operates strictly within peer-reviewed databases to ensure the foundation of the review is empirically sound. Once the initial query is complete, the researcher exports the validated literature as a batch of foundation PDFs. Those PDFs are then pulled into Node 2, the Notebook LM RAG environment, visualized here as the literature synthesis engine. Inside the vault, the AI engine rapidly extracts cross-paper themes and maps holistic research gaps across the entire batch of selected literature. This visual details the explicit prompt architecture required at this node to prevent the AI from generating unrequested or irrelevant variables. By defining precise column headers and brackets, requiring exact variables for objectives, methodology, and results, the researcher forces the engine to strict compliance. This output is exported natively as a structured Excel matrix, completing the internal processing phase. We then arrive at Node 3, the Open Generative LLM, Gemini. The researcher feeds the highly structured, validated matrix from the closed vault directly into the open system. Because the inputs are verified, the researcher instructs the model to generate testable research ideas and intervention models based on the documented whitespace. This triangulated pipeline bridges the gap between rigorous peer-reviewed sourcing and high-speed generation, allowing for rapid ideation built on a verified foundation. The synthesis process eventually yields a draft manuscript. This is the most vulnerable phase of research, requiring rigorous, adversarial critique before submission. Sending this unreleased text to an open LLM for feedback remains an unacceptable IP risk. This blueprint details a self-contained methodology built to bypass that risk. known as the critique inception loop. First, the researcher uploads the manuscript exclusively into the closed notebook LLM vault and initiates the audio overview generation tool. Crucially, the prompt parameters for this audio must be explicitly restricted. It is commanded to deliver a rigorous structural and methodological critique rather than a passive summary. Next, the researcher downloads the generated WAV file to a local hard drive and uploads it back into the same notebook as a new primary source. With the critique digitized, the researcher queries the AI to parse its own audio transcript and isolate improvements. The output is a highly specialized bulleted list detailing actionable revisions to the methodology and structure. By treating the conversational critique as raw data in the closed loop, the researcher achieves elite peer review simulation with zero IP leakage. This framework illustrates the full integration of these tactics into the profile of the augmented researcher. AI functions as an interconnected ecosystem of specialized agents structured to handle sensitive evaluation, visual teaching translation, and continuous closed-loop research. This framework establishes the hierarchy of every academic interaction. The researcher retains full control over the process, using the AI to process specific datasets rather than allowing the model to dictate the research direction. The researcher defines the methodology and establishes the ethical boundaries for every query. While these agents map latent data patterns at exceptional speeds, every generated bibliography, matrix, and critique requires manual validation against the source texts. The final theoretical contribution is constructed strictly by the human driving the system. Success in this new academic environment belongs to the system architect, the researcher capable of designing and maintaining these specialized multi-agent pipelines.